In this video, we're going to learn about a specific type of discrete random variable, which is called the binomial random variable, as well as the formula for the binomial probability distribution, as you see the title of this video, as well as some calculations we can do with it. Now, before we get into that, I need to describe what a binomial experiment is. So a binomial experiment is a random experiment that satisfies the following four conditions. One is you're going to repeat the experiment a fixed number of times, which we're going to call that n. So we're going to say before we do anything, we're going to repeat this 10 times. Or we're going to repeat this experiment 30 times. Or we're going to repeat this experiment 5 times. We're going to pick a number before we do it and then repeat it. If it's something that you repeat it and you don't know how long until you finish it, for example, let's say the World Series, where you repeat the game until someone gets 4 wins, that would not be a binomial experiment, right? Because before you start playing the World Series, you don't know how many games are going to get played. Whereas for a binomial experiment, you know ahead of time a certain number that you're going to repeat this experiment for. We'll call that n. And you have to keep that no matter if you're winning or losing throughout the games. The second is that each trial, this is when we're repeating it, has exactly 2 outcomes. So in the case of something like a World Series, but since it's not a binomial experiment, you win or you lose. You flip a coin, you get heads or tails. You roll a dice. You might say, wait a second, rolling a dice, there's 6 sides of a dice. But what if I say I get evens or odds? So if you interpret the problem in that way, there's exactly 2 outcomes. And we are going to call those 2 outcomes success and failure. Now, I want to point out something that is kind of unfortunate, that I don't know who decided to call these things success and failure, but one of the types of problems that I've seen in many textbooks is they'll say, okay, we have a couple that are decided they're going to have 4 kids, and here's the probability of them having a boy versus a girl, and then use the binomial probability distribution to find out the chance of them having 3 girls out of 4, or something that might be. Well, in that case, you need to call one of the outcomes success and one of them failure, and that just is a big problem, right? So it's unfortunate that we are deciding, this is what was decided by, I don't know how long ago, but we call the 2 outcomes success and failure, but they don't actually mean something positive or something negative. It's just a way to separate the 2 outcomes in some fashion that we all agree on. You can call it A and B, you can call it true and false, you can call it whatever it may be, but the standard in every book is success and failure. The third one is that the trials are independent. That means what happens in one of the trials is not going to affect what happens in any of the other trials. So if you're flipping a coin 5 times, the fact that you got a head on the second flip is not going to affect the chance of you getting a head on the 4th flip. They're completely separate chances. And the last condition is that the probability of success is the same for all trials. So if we're flipping a coin here, we can't flip a fair coin for a few of them and then switch into a weighted coin that's going to mess with the probabilities. No, the probability has to be the same for each and every trial. You could use a fair coin for all the trials, you could use a weighted coin for all the trials, but it has to be the same for every trial. And if you satisfy all 4 of those conditions, and your variable x is the number of successes, then x is called a binomial random variable. And binomial random variables end up popping up quite often in a lot of different scenarios. For example, let's say we are trying to poll people and decide if they're going to vote for a certain candidate. So you would say, are you going to vote for this person or are you not going to vote for this person? Those are your success and failure. And then you might see, well, okay, what's the probability that, 52% of the population are going to vote for this person and elect them? You would do a calculation, something like this. Now, there's a little bit more involved in that and talk about taking samples and things, which we'll get to later in the class. But there's a lot of real world scenarios that you can break it down into a yes or no situation where you repeat it over and over again. And the binomial random variable is just very useful for that. Now, one of the nice things about binomial random variable is you don't have to try to figure out the sample space. You don't try to figure out the size of any event here. If you want to find a probability, there's a very straightforward formula. I mean, it's a little complicated, but the probability that your variable is going to be exactly k, that means you have exactly k successes, is going to be that combination number with the number of trials, the number of successes, times the probability of getting a success, 2k power, times 1 minus p to the n minus k. So again, p is the probability of success. And I've said this, I don't know how many times in the videos already. I'll say it yet again today, and I'll say it again many more times in the future videos. Don't memorize this formula. I will again show you how to find this in the calculator. There's a nice little button where you tell it what your n is, what your k is, and what your p is, and you will get the answer for the probability. But this formula right here. So let's say I flip a coin 4 times, and I want to find the probability of 3 heads. Well, that would be the fact that I have 3 successes. If I call getting a head a success, there are 4 trials, 3 successes. The chance of getting a heads is 50% to the 3 successes. The chance of not getting a heads is also 50%, and there is 1 failure. And if I put this in my calculator here, and times C for 3, I get a 25% chance that I will get exactly 3 heads when I flip the coin 4 times. So again, we aren't usually going to use all the detailed formula here we're going to put in our calculator, but this is how you can calculate these probabilities anytime you have a binomial random variable. Now in the previous video, we learned that if you ever have any discrete random variable, you can calculate the mean using this formula, and you can calculate the standard deviation using this kind of ugly formula here. And you could do that with the binomial random variable, and it would be a lot of work. I don't recommend doing that. However, it turns out there is a shortcut that only works for binomial random variables. And I can tell you what it is right now, that the mean for any binomial random variable, the mean is going to be take your number of trials, multiply it by the percentage chance of success, and your standard deviation is going to be the square root of n times p times 1 minus p. So it turns out if you do all these complicated formulas over here and combine that with the formula for the individual probabilities here, and almost like the double complication makes itself cancel out and it makes it simpler. And this ends up giving you your mean and standard deviation without doing all the hard work. So occasionally I will describe a binomial experiment situation, ask you what the mean or standard deviation are. And this is the way you're going to want to do to actually